Calculating enthalpy change and determining the mass. Well, in this question, it's asking for the mass in kilograms of methanol being combusted to generate this much energy. Is this energy going to be for the enthalpy change of the whole reaction, or is it going to be for the standard molar enthalpy? It's obviously going to be for the whole reaction here, because it's not stating in the question that it is per mole, okay, of methanol. It's just for the whole thing. It's a general amount. So we're just going to be putting this on the far left side so it matches this one in the formula. Please put a negative sign there so that it is exothermic, it is releasing energy, is equal to the amount of moles multiplied by the standard molar enthalpy. We can find that value right over there in the table, right? You can see that value of negative 726.1 kilojoules per mole. So for every mole of that methanol, it releases that much energy. Well, we have to divide this, right, with that same value so that they can cancel out. So I'm only going to be left with my amount of moles. So I have 742.32, and then we're just going to get that same value here. We don't want moles, we want mass in kilograms. So I have to multiply by the molar mass. Moles and moles cancels out. You can find it on the periodic table. What is the grams per mole of methanol? It'll be 32.05. Find the product of that. You end up getting 23,791 grams. You can backtrack this so that you end up getting 0.791 kilograms. Next question here, we have to find the thermochem equation. Well, I've already started it here. I've made the unbalanced chem equation. I have to balance it first, so I'm just going to be putting a 2 here, a 9 here, a 6 here, and an 8 over there. Now, this is also per mole released, right? This is the standard mole enthalpy, so I'm putting 2006 kilojoules. And we've realized after we balanced that out that there's a 2 mole over there, so I have to multiply it by 2. It's not per mole anymore because there's 2 moles after we balanced it out. Well, also in that same question, it says of 1 mole of this compound, so then we actually have to go backtrack again. Instead of using 2 moles, we have to divide by 2, so everything else has to divide by 2 as well, even this one here as well. So this here is our thermochem equation. Next, how much heat is given off when 25 grams of water is produced? Well, I have my water over here. I'm multiplying it by the molar mass, and I'm again my certain amount of moles of H2O. But this whole time we've been dealing with the propane 2-ol, so we have to change this back and revert back to the propane 2-ol. Well, we have to do the molar ratio. So for every mole, as you can see, for every mole, there's 1 mole of propane 2-ol here. There is 4 moles of the H2O. So I have to put that over here. Multiply by that quarter, I end up getting 0.34675. I'm going to put that same value over here. Multiply by the standard mole enthalpy that was stated here at the very beginning. I end up getting a value of negative 695.58 kilojoules.